So just to review, positive and negative angles. If I have a positive angle, like say I want to graph or plot positive 90 degrees, we'll start off easy. I'm going to start on my x-axis and I'm going to go counterclockwise. So 90 should be here. If I keep kind of following it around on my axes, this would be 180. This would be 270. So again, to get 270, if I drew the angle, it would open up all the way to there. If I went all the way around, I know sometimes we all have little silly things, but remember, all the way around any circle is 360 degrees. So positive angles go counterclockwise, and you can use these axes as your reference points, 90, 180, 270, 360. If I'm talking about a negative angle, negative angles go clockwise. So you're going to start on the positive x-axis. You always want to start on your x-axis. Remember, x is the boss. That's why we call it the independent. But clockwise, so think of the direction a clock spins, right, is going to go this way. So this would be probably about like 40 degrees if I had to guess. So if I kept going if I kept going, this would be negative 90. Keep going around all the way to here would be negative 180. All the way to here would be 270. And then all the way around my circle clockwise would be negative 360. So I hope that helps. When we talk about angles, again, I want you to think of your x being your starting point. That starting point is the initial. So our initial side is along the x-axis. This other side over here, they call the terminal side. So think about when you're at the airport, when you have to go to the terminal, but this is the terminal side. All right, so if I want you to tell me the reference angle pretty much is saying in reference to the x-axis. Remember, the x-axis is the boss. So from the angle's terminal side to the x-axis, it needs to be positive, and basically we're just saying what is the shortest distance from the x-axis. So something else I want to just pause a second and review. When we have our coordinate plane, so here is our x-axis, and here's our y-axis, and this is really going on forever. So it's two number lines intersecting at the origin, right? This is quadrant one. Quadrant one, we have positive, positive. Quadrant two is negative, positive, meaning x is negative, y is positive. Quadrant three would be negative, negative, x is negative, y is negative. Quadrant four is positive, negative, x is positive, y is negative. So if it helps you, we can write where they're negative and positive, all stuff you should know. I know I had a teacher that said, think about writing a C. Math teachers love to say, check your work. The directions of the quadrants go 1, 2, 3, 4. This would be counterclockwise, which also starts with a C. Okay, so all of that was just to review what you probably learned in 6th or 7th grade, depending. All right, quadrant one. So if we have an angle that is in quadrant one, so we'll just focus on positive angles right now. Let's say I have the angle that is 70 degrees. I know quadrant one has to be between 0 and all the way here is your 90-degree angle, right? So it's got to be somewhere between 0 and 70. So if I want the reference angle and I'm in quadrant one, it's just simply going to be that angle, because if I think about the distance, so here's my 70-degree angle, right? This is opening up 70-degree angles. If I'm asking the reference is saying, how far away, guys, is this 70-degree angle from the x-axis? Well, it's 70 degrees. Quadrant one is pretty easy. Quadrant two, so now if I'm thinking quadrant two, I'm thinking I'm somewhere over here. So this is 90 if I'm doing positive direction, and this is 180. So let's pick an angle between 90 and 180. Let's say that this angle right here is 110 degrees. So here's my initial side. I open up. My terminal side ends to be in quadrant two. So if I'm asking you reference angle, Well, the shortest distance to the x-axis is not this way. So I do not want to go that way. I want to think it's closest to this side of my x-axis. So what is the distance from 110 to 180? In other words, 180 minus that angle would mean my reference angle would be 70 degrees. The angle that's 110 is 70 degrees away from my x-axis. That's what a reference angle is saying. How far away is the terminal side of the angle from the x-axis? All right, let's look at quadrant 3. So quadrant 3 is over here, and I know this is 180, this is 270. So angles in quadrant 3 are between 180 and 270. Let's pick, say, 240. So we'll say I'm looking at this angle that's 240 degrees. Here's my initial side. This is called my terminal side. So if I want my reference angle, they are asking you in reference to the x-axis, how far away is 240? So I'm going to think it's got to be positive because it's the distance. 240, the closest side would be here. I don't want to go here. That's a bigger distance. Shortest distance back to the x-axis would be 240, my angle, that's what that theta means, minus 180. So I would get a reference angle equal to 60 degrees. Quadrant 4. All right, so quadrant 4, I'm now between 270 and 360. I'm somewhere over here, and I want to pick a number. Let's say we use 300. So my angle goes all the way around to 300 degrees. How far away is it from my x-axis? Well, I don't want to go back here. You definitely don't want to go, this is the y-axis, so don't think about going there. You don't want to go to your y-axis. We want to think about our distance to the x-axis. So if 300 is here, shortest distance to the x-axis would be 60. So you're thinking 360 minus your angle. There's that theta sign again. All right, so graph each angle in standard position. So I just wanted to remind you, if we're talking positive, we have 0, 90, 180, 270, 360. So let's say we wanted 275. 275 is between 270 and 360. So if I draw the standard position of 275, I'm going to draw my initial side and go all the way around, and we're just going to estimate it to be a little bit past 270. So if I were to grade your work, I would be grading that 275 is in quadrant 4. Check. Okay, now state the reference angle. So reference angle means how far is this from my x-axis? X-axis, not y-axis. So I want to think 360 minus 275, because this is 360, that's the closest point there. So my reference angle for this one would be 85 degrees. Okay, let's try another one. If you're brave, you can pause it and try it on your own. All right, so this one's a negative. So, oops, I don't know why I have that green line. Sorry about that. But if I'm going negative, I want to think this is 0, negative 90, negative 180, negative 270. These are all degrees, negative 360. All right, so negative 140 should be somewhere here between negative 90 and negative 180. I'm going to draw my initial side, and I'm going to go clockwise right there. So there's the negative 140. I know that's in quadrant 3. In terms of my reference angle, I'm thinking from here, which is negative 140, to negative 180, because that's my x-axis. How far away is that? Well, that would make my reference angle 40 degrees. All right, try 3 and 4 and then come back. So pause, try it. All right, let's do it. So this one's a negative, so I'm going to go clockwise. Negative 180, negative 270, negative 360. All right, negative 50, this is also 0. Negative 50 should be somewhere here. It's a little bit more than halfway, but we don't even need to worry about that. There's my initial side. I'm going to open it up clockwise, and I am in quadrant 4 if it asks me. So there's my angle. Now, in terms of a reference angle, reference is asking you in reference to the x-axis, how far away is this one? Well, I went 50 away, or I could think negative 50 is from 0, 50 degrees. 380, well, that's a little tricky. So it's positive, so I have 0. I want to go counterclockwise. 90, 180, 270, 360, still not there. So I could just keep adding, right? Every axis to axis is 90 degrees. Or you can think, all right, here's my initial. I'm going to go all the way around and then a little bit more. So this one is in quadrant 1. And we're going to talk about this angle. So this is 380 degrees. So I went all the way 360 and then 20 more. So it's pretty much the same as drawing a 20-degree angles. And these are going to be called coterminal because they share a terminal side. If I were to graph 20 degrees, it would be the same as 380. All right, in reference to the x-axis, so here's my x-axis, it's 20 degrees away. So it's only 20 degrees up, so reference angle would be 20 degrees. All right, what is a radian? So a radian is if we take a radius. So let's imagine the radius of this circle that's here, and we're going to really dive into unit circle coming up, but let's imagine the radius of this circle is 5. I could imagine taking this piece of string. Let me just get rid of some of this other. So if I cut a piece of string and I started going around the circle, I would have 1 radius, 2 radius, and then 3 and a little piece. That little piece, if we actually measured it out, would be exactly 3.14. And 3.14 is pi. So it actually wouldn't be exactly 3.14 because it exactly measures out to be pi. So if we go halfway around a circle on a coordinate plane, this halfway spot, well, all the way around is 360, so halfway is 180, is considered pi, meaning that it's 3 and a fraction of the radius that is here. Okay, so big idea here. Pi is 180. So if I want to go all the way around the circle, or 360 degrees, I would say that would be 2 pi. 1 pi is halfway around. 2 pi would be all the way around. Okay, write that down because this would be really, really important for next week. All right, convert from degrees to radians. So remember, let's say I had 10 divided by 10. 10 divided by 10 is simply 1, right? Anything x over x is 1. 2x over 2x, 1. 5ab squared over 5ab squared. Anything over itself is 1. Well, if pi equals 180, or I could say 180 degrees equals pi, I am allowed to multiply by pi over 180 because essentially I'm just multiplying 180 by 180, or I could think of it as pi over pi, which is a form of 1. So if I start with the degree, I want to undo the degree by dividing. So we're going to divide by 180, and then we're going to put the pi back. Easiest way to do this is in your calculator, do 300 divided by 180, and then hit math fraction. If you don't have a fancy calculator, go ahead and just simplify those. So you should know that the zeros definitely go away. What goes into 30 and 18? Well, 6 does. 6 goes into 35 times. 6 goes into 18 3 times. So in radians, put that pi back, this would be 3 pi over 3. 3 pi over 3. Negative 180, same thing. So I'm going to divide by 180 and multiply by pi. Pi over 180 is a form of 1. So 180 over 180 reduces to be 1. And in terms of radians, I would have pi. Something you should notice, degree always has this little degree, unless they have a typo and they forgot to put it. Radians I would say like 98% of the time has a pi sign. If it doesn't have a pi sign, it's going to be like a 1.2, a really small number. All right, 55, negative 55 degrees into radians. Go ahead and try that before I do it. So press pause and try. All right, so we're going to multiply by pi over 180. I would look at this part first. So if you want to, you can literally just do negative 55 divided by 180, math fraction, and my calculator tells me negative 11 over 36. And then I want to just put this pi symbol back. All right, can we go the opposite direction? So now, instead of undoing the degree and adding the pi in, I'm going to undo, so divide out the pi and then multiply by the degree. Remember, this is just a form of 1 since 180 degrees equals pi. It's just multiplying by a form of 1. All right, so I'm going to multiply by 180 over pi. So these cross out and become 1. And now I'm just looking at 180 divided by 4, which most of you should be able to do in your head, 45. And I want to make sure I have the little degree there. Another way that you will see if you look online is sometimes, since 180 equals pi, they say that you can just take this 180. So if I had the same problem and I want to sub it in, I could just simply sub in 180 degrees for the pi and just do it that way. Either way is fine. I will just caution you that some of them, like when you do the Delta Math assignment, some radians do not have a pi, so that substitution method will not work for when the radians is, say, 1.2. Because if it's giving you 1.2 radians, you're going to need to do 1.2 times 180 divided by pi in order to get it to be a degree. So that one would be, we always leave it in terms of pi, so I would just write 260 degrees divided by pi. And then if they wanted you to round it, you could round this to be about 68.75 degrees. All right, let's look at the next two. So go ahead and try them before I go over them. All right, so I am going to multiply by 180 over pi. This is why I like that we just did the rational unit. So these pi's get eliminated to be 1, 180, and 6. Well, 6 goes into 183 times, and now I just have 5 times 30 is 150 degrees. Okay, let's look at the last one. So I'm going to multiply by 180, divide by pi. All right, these pi's get eliminated. 180 divided by 4 is 45. We actually did that up there. And then I just need to do 45 times 3, which gives me negative 135 degrees. All right, moving on. Coterminal. So we briefly talked about this before, but co means that you are doing it together. If you are a co-captain of a sport, you are a captain along with someone else. If you are a co-pilot of a plane, you are a pilot along with someone else. So co-terminal means that they share this terminal side. So the terminal side is the one that opens up away. This one's the initial, this one's the terminal side. So if I want to be the same terminal side and I'm thinking degrees, it's really easy. All I need to do, oops, sorry about that line. All I need to do is go ahead and add 360 degrees. Why 360 degrees? Because that's a full circle. So if I want a positive to 45, I'm just going to do 45 plus 360, and I would get 405. I could literally keep adding 360 for eternity because there are unlimited coterminal here. I can keep going around and around and around and around and around, right? If I want a negative, very similar. I just want to subtract 360 because I want to subtract a full circle to get back here. So if I'm thinking 45 and I want a negative, that's going to be negative 350 degrees. I can take negative 315 and subtract another 360. So some coterminals of 45 are 405, 765, negative 315, negative 675, and you can keep adding and subtracting. Now, if they were to ask you to find a coterminal for a radian, in radians, remember, all the way around a circle, a full circle in degrees is 360. A full circle in radians is 2 pi, because remember, here to here is pi, and in order to go all the way around, I need 2 of those. All right, so let's try some. Give one positive, one negative angle, and then unpause. So pause, try it, and come back. All right, positive, I'm going to add 360, so that would give me 390. Negative, I'm just going to do 30 minus 360, so negative 330. That is 1. There are unlimited. All right, negative 250, I'm going to add 360, and that gives me 110 degrees. Negative 250 minus 360 would give me negative 610. 450 minus 360 leaves me with 90. That's a positive. I could have done 450 plus 360 and used 810, but it's only asking for 1, but there's 2. All right, so if I want a negative, I'm actually going to have to subtract from 450 twice, because if I subtract 360 once, I'm only at 90. So I need to subtract 450 minus 360 minus another 360 gives me negative 270. Let's look at what this looks like in terms of pi. So if I had radians, and the hint that I'm in radians again is that there's a pi symbol there. All the way around the circle is 2 pi. So I want to add 2 pi, which means I need to get common denominators here. So that would be 4. So if I want this to be 4, I need to multiply by 4 over 4. So that would be 8 pi. 8 pi plus 1 pi is 9 pi. So 9 pi over 4 would be my positive. And then if I want my negative, I'm just going to do pi over 4 minus 8 pi over 4. 8 pi over 4 is an equivalent form of 2 pi. So 1 pi minus 8 pi is negative 7 pi over 4. Okay, if I'm looking at the second one, go ahead and pause it and try it and then come back. All right, so if I need to add 2 pi with a denominator of 6, 2 pi is just going to be 12 pi over 6, because I'm going to multiply top and bottom, by 6. So I'm going to do 5 pi over 6 plus 12 pi over 6 to get a positive. So that would give me 17 pi over 6. And then if I want my negative, I'm going to do 5 pi over 6 minus 12 pi over 6. So 5 minus 12 gives me negative 7 pi over 6. All right, hope that helps. Here is a question that you will see in Delta Math. It's in this form, so I did just want to review what this is saying. So the first section in Delta Math, you're going to have 3. One is going to be just go from radians to degrees. The other one's going to go degrees to radians. And then there's one section that looks like this, where it's asking you multiple things. So it's saying I have 1,127 degrees. Why they use such big numbers, I'm not really sure. But remember, I can find a coterminal one that easily fits between 360, because I know if this is positive, I'm going counterclockwise. Whoops. Hopefully you guys got this part of there you go, that's 80, 90, 270, 360. So I probably want to go ahead and take 1,127 and subtract 360. That gives me 767. Still too big for me. I like it to be between 0 and 360. So I subtract 360 again, and I get 407. Getting better, but let's just do one more time. So subtract 360, I subtracted 360. I'm going to do it one more time, and that leaves me with 47 degrees. So this angle here is really 47 degrees. So I'm going to put that here. There's my initial side, here's my terminal side, and I'm at 47 degrees. So if I needed coterminal angles, 767 is a coterminal angle, 407 is a coterminal angle, 47 is a coterminal angle. I could subtract another, and I could get negative 313 is another coterminal. They're asking us for the coterminal that's between 0 and 360. So the coterminal that's between 0 and 360 is 47 degrees. What quadrant is this in? Well, this is quadrant 1, 2, 3, 4. So this is quadrant 1. Find the reference angle. So reference angle means distance to x-axis. X-axis, guys. I'm sorry. Sometimes it just goes crazy. X-axis, and it's a distance, so it's got to be positive. So how far away is this from the x-axis? 47 degrees. All right, guys, go try that delta math assignment.